So we all know large language models are amazing generalists, right? But what if you need a specialist? How do you actually teach an LLM to become an expert in your specific field, whether that's law, medicine, or even just your company's internal lingo? Well, it's not magic, it's engineering. And today, we're breaking down the complete blueprint for fine-tuning these incredibly powerful models.
Now, if you think fine-tuning is just about throwing a new data set at a model and hitting train, you're missing the most important part of the story. Seriously, that's just one single step in a much bigger, much more disciplined process. The real breakthrough happens when you stop thinking about it as this one-off event and start seeing it for what it is, a complete engineering pipeline.
All right, so here's our game plan. First, we're going to get a bird's-eye view of the entire 7-stage pipeline. Then we'll get our hands dirty with the super important foundation work. After that, we dive right into the heart of the process, the training itself. And finally, we'll see how to take our brand new specialist model and actually launch it into the real world. So, let's get started.
Before we dive into the nitty-gritty of all the code and data, let's just zoom out for a second. Imagine we're planning a huge expedition. You'd want to see the whole map first, right? The mountains, the rivers, the final destination, before you even take your first step. That's exactly what this first section's all about, understanding the complete journey from start to finish.
And here is our map. It all kicks off with the most critical ingredient, the data. From there, we pick and prep our base model. Then comes the core of the operation, this cycle of teaching and testing, fine-tuning and validating. But here's the thing, the journey doesn't just stop when the training stops. We then have to launch our model out into the world, and this is crucial. Keep an eye on it to make sure it keeps performing the way we expect. It's a full life cycle, you see, that turns a generic model into a highly specialized expert.
You can't build a skyscraper on a weak foundation, right? And the exact same thing is true for AI. The success of this entire pipeline really hinges on the quality of these first 3 prep stages. Get these right, and you are absolutely set up for success.
Stage 1 is all about the data. And let me be perfectly clear, this is the most important step in the entire process. There's an old saying in machine learning, garbage in, garbage out. The quality of your fine-tuned model will never be better than the quality of the data you use to train it. That means we have to be meticulous, collecting the right info, cleaning out all the noise, and structuring it perfectly so the model understands exactly what we're trying to teach it.
This is exactly what that transformation looks like in the real world. Over on the left, you've got raw, messy, human input, and on the right, you've got the clean, structured format that the model actually needs to learn from. This isn't just about cleaning up a few typos. This formatting step is so important. It's how we teach the model the exact style and structure of the answers we want it to get back.
For stage 2, we're not starting from scratch. I mean, that would take millions of dollars and months of time. Instead, we get to stand on the shoulders of giants. We load up a powerful, pre-trained model that already has a deep understanding of language. This initialization step is really all about getting that base model ready for its new specialized education.
Okay, in stage 3, we build our digital workshop. Fine-tuning an LLM is like trying to solve a billion-piece puzzle, and that requires some serious computational muscle. So this is where we set up our high-performance hardware, the GPUs and TPUs, and all the software frameworks. Think of it like preparing the forge, where we're about to shape our model.
A huge part of setting up our workshop is tuning the controls. These are called hyperparameters, and they are absolutely critical. The learning rate, for example, is kind of like the gas pedal. If you go too fast, you crash. Too slow, and you'll never get where you're going. The batch size decides how much data the model looks at in one go. Getting these settings just right is both an art and a science, and it's essential for a successful run. Okay, foundation is laid. Now for the main event, the training itself. This is where the magic happens, where the actual learning takes place. It's kind of like a dance between teaching the model new skills and then rigorously testing its understanding. Let's dive in.
So the traditional method is called full fine-tuning. This is the most thorough way to do it, where you update every single one of the billions of parameters inside the pre-trained model. Think of it like taking an entire car engine apart and rebuilding it piece by piece for maximum performance. It's incredibly powerful, but as you can imagine, it's also incredibly resource-intensive.
But what if we don't have the resources to rebuild the entire engine? Well, that's where a more modern and frankly, much smarter approach comes in. Parameter-efficient fine-tuning, or PEFT. With PEFT, we're not rebuilding the whole engine. We're acting like a master mechanic, making small, precise adjustments to just a few key parts. We freeze the vast majority of the model's parameters and only train a tiny fraction. This is a total game changer, making fine-tuning accessible to so many more people and projects.
And this slide shows you exactly how clever this is. On the left, you see regular fine-tuning, where you have to update that entire massive block of weights. But look at the right. That's a popular PEFT technique called LoRa. Instead of changing the original weights, it just adds 2 tiny new matrices. The number of parameters we have to train is a tiny fraction of the original, which means we can do this with way less computing power. It's such an elegant solution to a massive problem.
So we're training the model, but here's the million-dollar question. How do we know if it's actually working? How can we be sure it's genuinely learning and not just, memorizing the textbook? That's where the most important feedback loop in this whole process comes in: evaluation and validation.
While we're training, we keep a really close eye on a few key metrics. One of the most important is the loss curve, which is basically just a graph that shows us how many mistakes the model is making over time. Ideally, we want to see that error rate go down, down, down. But we have to be really careful of a common trap called overfitting. That's when the model gets an A+ on all of the practice tests, but then completely bombs the final exam because it just memorized the answers. The goal isn't memorization, it's generalization, the ability to perform well on new problems it's never seen before.
All right, we've trained and validated our model. It's a specialist. Now what? Well, the final phase of the pipeline is all about taking this powerful AI out of the lab and turning it into a reliable, useful product in the real world.
Stage 6 is deployment, getting our model out of the lab and putting it to work. First, we optimize it for speed. We use techniques like quantization, which basically makes the model's brain more efficient so it can think faster. Then we decide where it's going to live: in the cloud, on our own servers, maybe even directly in a web browser. And finally, we build the robust infrastructure needed to handle requests from potentially millions of users.
So the model is live, it's answering queries. The job is done, right? Well, not quite. The world isn't static. New information comes out. User behaviors change. A deployed model isn't a finished statue, it's a living system that needs constant care.
And that brings us to stage 7, monitoring and maintenance. And listen, this isn't an afterthought. It's a continuous, never-ending loop. We monitor the model's performance in real time, looking at things like accuracy and how fast it responds. We periodically retrain it with new data to stop its knowledge from getting stale. A truly responsible AI system is one that is cared for throughout its entire lifecycle.
So let's just take a step back and admire the blueprint we've just constructed. We've seen how a vague idea can be transformed through a systematic engineering process into a powerful, living, learning product.
And here it is again, the full pipeline. We started with data prep and initialization, we moved through that core loop of fine-tuning and validation, and we finish by deploying and maintaining our model. See? It's not just one step. It's a cohesive, repeatable engineering process for creating truly specialized AI.
We've covered the strategic blueprint of the fine-tuning pipeline, but now it's time to get tactical. In our next chapter, we're going to dive deep into the specific techniques that make all of this possible. We're talking LoRa, QLoRa, and other really cutting-edge approaches. You are not going to want to miss it, so make sure you subscribe. Thanks for watching, and I'll see you in the next one.